So after having discussed relationship sets conversion to tables, we can look at the next topic basically, and basically some review about the key constraints, right? So each department at most has one manager according to the key constraint on managers, right? This is one thing we discussed before, right? So every department would going to be having one manager, right? So in the managers relation, the DID would be unique, right? Because there would be one entry for one department ID. So basically translation to relational model, and these are basically the mappings that we discussed previously: one to one, one to many, many to one, and many to many. Okay, so how we can translate to relational model? Map relationship to a table. Note that DID is the key now, right? So as I discussed before, when we created the managers table, right, SSN, DID, since, and the primary key for managers is DID, right, because of this particular arrow that I discussed before. So after that, the primary key is DID, and what is the foreign key? Foreign key is the SSN, and foreign key is the SSN, which references of course the employees, and DID is also the foreign key and it references the departments. So because we have separate tables for employees and departments, since each department has a unique manager, we could instead combine managers and departments. So since each department is having one unique manager, we can also create something like this: create table department underscore manager. DID would be an integer, DNAME, budget, SSN, since, and the primary key of course would be the DID, and the foreign key would be the SSN that it references the employees. That is, we can see that we have combined the department and managers tables. Can everyone see? Because DNAME was in the department, so it is now occurring in the same thing. So we have used aggregation and we have combined department and manager. So both of these approaches are correct as far as the design is concerned. Let's now look at the participation constraints, right? And participation constraints, can everyone recall? It was full participation or partial participation, isn't it? That is the thing. So the question is, does every department have a manager? If the answer is yes, this is a participation constraint. The participation of departments in managers is said to be total versus partial. So what do we mean by this? Every department ID value in the departments table must appear in a row of managers table with a non-null SSN value, right? So in the managers table we would have SSN, we would have since, and we would have DID or the department ID. So now since every department has got a manager, so every row, every DID would be included in the row of the managers table, and corresponding to each row there must be a non-null SSN value that would be indicating the SSN of the manager. So that is the idea. So now that is the something that we discussed previously also. So how do we implement participation constraints in SQL, right? So we can capture participation constraints involving one entity set in a binary relationship, but little else without resorting to check constraints. Okay. So in binary relationship we can have easy implementation of participation constraints. We have other methods in ternary relationships. So what do we do? Create table department manager, DID integer, DNAME is a character, budget is real, character is SSN is 11 characters, and it is not null, which is specifying that SSN should be a non-null value for all the rows that are inserted into the department manager table. We have the sense field, we have the primary key, which is DID, we have the foreign key SSN, which references employees, of course, because employees contains the primary key of employees contain SSN as the primary key. And on delete we have no action. The no action means we don't want to carry out any deletion process for this particular key as for SSN, as certain conditions hold, like I discussed before. Now a review about weak entities. We discussed before that a weak entity can be identified uniquely only by considering the primary key of the another owner entity. Remember the discussion? So one primary or strong entity can have many weak entities. For example, dependents, right? So one employee can have many policies for some dependents. So total participation, right, of the weak entity set. This is something I already discussed in the previous lecture. So how we'll translate the weak entity sets? Weak entity set and identifying relationship sets are translated into a single table, right? So when the owner entity is deleted, all owned weak entities must also be deleted. That is logical. If the owner entity is deleted, all the weak entities that are owned by that owner entity must also be deleted. So we have created table department underscore policy. This is the policy holder's name. Weak entity attributes, cost, SSN, again not null. And what would be the primary key? Like we discussed before, primary key would consist of the policy holder's name and the SSN combined. And foreign key is SSN, which references employees, and we have on delete cascade. So if a certain department policy entry is deleted, right, so this is the thing, right? So SSN must reference the primary key of the employees. So that is the definition. So afterwards we will have the is hierarchies, right? And is a hierarchy, we discussed that hourly employee is a employee, contract employee is a employee, and we discussed about the how the attributes are inherited. Remember that discussion? If you don't remember, you can follow my earlier lecture 2 discussions. We also discussed about overlap constraints. Can Joe be an hourly employee as well as contract employee? Is it allowed or disallowed? Covering constraints, does every employee entity also have to be an hourly employees or a contract employees entity? Yes or no? So these were the questions, remember, that we discussed. So we can have this general approach towards translation of is a hierarchies to relations. So how can we translate is a hierarchy to relations? What is the general approach? Let's see. We could have 3 relations: employees, hourly employees, and contract employees. So in hourly employees, every employee is recorded in employees. For hourly employees, extra info is recorded in hourly employees. And what is that extra information? Hourly underscore wages and hours underscore work and SSN. And we must delete hourly employees if the reference employees tuple is deleted, of course. Of course, if an employee is an hourly employee and we delete this tuple, we should delete this tuple if that SSN is deleted from employees. And queries involving all employees is easy. Those involving just hourly employees require a join to get some attributes, right? So this is one point I want you people to think about and just try to find out what this means. And what is an alternative we can have? Just hourly employees and contract employees. We don't make an employees table, we make hourly employees and contract employees. Hourly employees would contain the field SSN, name, lot, hourly wages, hours underscore work. So each employee must be in one of the 2 subclasses, right? That is the idea. Okay, so what is a view? A view is just a relation, but we store a definition of a view rather than a set of tuples. Remember, I said that the view is not a table. That is the reason why it's not a table, because we store only the definition or the schema of the view, not the instance of the view. So we can have create view, young active students, and basically the parameters would be name and grade, as select s.name e.grade from student students S enrolled E, where s.sid equals e.sid and s.age is less than 21. So what is this thing that we are applying over here? Equijoin, right? So the name of the view is young active students, and what are the two values we will be having? Name and grade. And how that name and grade will be selected? Based on the joins, because grade would be coming from enrolled table and name would be coming from the students table. Similarly, views can be dropped using the drop view command. So how to handle drop table if there is a view on the table? Drop table command has options to let the user specify this. So that's an important thing. If I want to drop, for example, students table, but student table is being used in this view, young active students. So what to do? Like other options, we can set options for this command as well. So views go a long way in implementing security in the DBMS. So views can be used to represent necessary information or a summary while hiding details in underlying relations. So views can be used for information hiding, right? What is the example? We developed a view young students, right? But we are only referring to young students. We are not referring to students or enrolled. And that I am talking from the point of view of a user. So we can find students who are enrolled, but we cannot find the information of the course IDs of the courses they are enrolled in. So this is basically basis for information hiding. So finally, some summary of the relational model. Basically, relational model represents a tabular representation of data. It is simple and intuitive, and it is currently the most widely used. And integrity constraints can be specified by the DBA based on application semantics, or in other words, the real world situation for which the DBMS is being developed. So we have two important integrity constraints, primary and foreign keys. And in addition, we always have domain constraints that have been discussed before. So why is the relational model so good and so powerful and so unique? Because it has got a powerful and natural query language. So rules to translate ER to relational model are there, and we have looked at them. So that brings us to the end of the chapter 3 discussion. Take care.